Hello, my name is Eduardo Martins and this is my video lab report for Lab 1. The objective of the lab in question is to compare the computational results of a simulation to real-world observations of a simple uniform rectilinear motion. We're gonna see that it's very hard to replicate such an ideal situation. In this case, we're gonna be using Newton's second law of motion, which states that the change in velocity over time of a body, its acceleration, is directly dependent on the existence of a force acting upon it, F equals ma. Since there's supposedly no net force acting upon the body in the video, its velocity should never change, and therefore we observe a uniform rectilinear motion. I chose to roll a bottle because it's much easier to mimic the lack of friction with a rolling motion when compared to a sliding motion. In this case, the system being analyzed is composed of a rolling bottle and the ground it's in contact with, which provides a normal force that counteracts its gravitational pull. That way, the net force throughout the experiment should be zero. Now let's look at the video I recorded. At the beginning of the experiment, I give the bottle a quick push, an impulse, that provides enough force to overcome the friction with the floor, and the bottle engages in its motion. Unfortunately, as we can conclude from the analysis of this video using tracker, the movement we observed wasn't completely uniform. That's because, in the real world, there is actually some friction still occurring in the contact surface of the bottle with the floor, since it's rolling with some degree of slipping, which takes away a bit of its kinetic energy over time. The idealized computer simulation used in this experiment was made using GlowScript, and it's a basic iterative process of incrementing the position over time based on the initial velocity, which doesn't change, and the starting position, which can be determined with tracker. Here I decided to use the average velocity from the real-world observations, since over the course of the 2 seconds in which the experiment takes place, the total distance traveled should be the same. Now, if, when analyzing the data in tracker, I had flipped the axes and interchanged plus x with minus x, my results would have been exactly the same but flipped in relation to the x-axis in the end graph, and the analyzed position would have been positive instead of negative. We can then conclude that it is in fact possible to create a reliable model to be simulated with a computer, given that we adjust the system, the starting conditions, and the period of observation in such a way that the model is approximately equivalent to the real-world situation. In this specific case, some adjustments are yet to be made.